Yeah.
So it's a pleasure for each and every one of you to be here. Yesterday we had a very powerful session from Mr. Dr. Tony, and I actually introduced him but for those of us that will be joining today, I'm going to just have a very quick rundown of what we are doing. So we are currently the Southeast Association of Public Health Students. We deemed it fit to organize a public health data analysis series here now in November, sorry. And we're also looking forward to organizing other programs for our students. So part of the benefit our students have to enjoy or are looking at to enjoy now is, having themselves trained in data analysis, particularly SPSS, how to use statistical package for social sciences. And the person who is facilitating this session, it's somebody who has been a very renowned researcher, with a lot of experience in the field. And I would just want to introduce him again for some of us that are joining for the very first time. So we have Dr. Tony here with us. He's a public health expert and he's passionate about teaching, developing public health projects and making positive impacts on people's health and well-being. He has strong interest in cancer epidemiology, especially towards the development of biomarkers to effectively predict cancers and inform prevention and treatment strategies. So Dr. Tony has currently completed his master's degree in public health at the University of Bradford in the United Kingdom, where he learned, and where he has a lot of advanced skills and knowledge in public health research, practice, and policy. So he's currently a Cochrane mentee in the US network of Cochrane workers, and he has collaborated with numerous, renowned professors in research, and is currently a graduate research assistant at the University of Bolton in the United Kingdom. So he's very skilled with lots of statistical tools like in vivo, SQL, R, Microsoft Excel, and Power BI. So Dr. Tony is somebody that has mentored over 50 students in epidemiology. And I'm sure the vast majority of our participants here are public health students. And as a matter of fact, we understand what epidemiology is, and we know it's a very critical aspect of public health. So in our last session yesterday, he gave an overview of how we can use, a questionnaire, in performing data analysis. And he did a lot of, he did the descriptive statistics. He showed us how to queue in the data into the SPSS software. And today we are going to have a continuation of that particular session, so that at the very end, each and every one of us will have, that needed knowledge. So I want to encourage our participants, please, you have to try as much as possible to ensure that you get the SPSS software. The SPSS software is something that whenever you have the knowledge of this, the SPSS software is a software that, sorry, I just admitted lots of persons. So the SPSS software is a software that enables you to, make a lot of, perform a lot of vital analysis in public health. So I would hand over to Dr. Tony, to commence the session. Thank you very much, Dr. Tony. God bless you.
I welcome everybody again to this session. Before I start, I will just quickly give a brief recap of what we did yesterday, maybe just in 5 minutes. So what we did yesterday, I emphasized on the need to master Excel and SPSS. Basically, I think it's mandatory, Excel and SPSS. Then if you have more time, you can go into learning Starter and learning R, especially if you want to go into the area of epidemiology. So that's just a brief overview. Then secondly, we went into looking at what SPSS software looks like. So when you open the software, initially it looks like an empty space, okay? It just looks like this, okay? And then we said that the there are two views. You can see here the variable view. The variable view is where you code your questionnaire itself, okay? And then we say that the data view is where you enter the answers of, that's like what people, the options that people chose in your questionnaire. So the variable view is for coding the question itself, and then the data view is for entering the options. That's the responses. So that's what we said yesterday. And then we used a sample questionnaire given to me by David, and we practiced how to code for how to enter those questionnaire inside the SPSS. Okay, so then we said that, let me just open it. So we said that these are the questions. This is variable view. So we said that if the options are in groups, if they are categorized, then even if they are numbers, so far as that they have categories, for example, look at age here, 18 to 24, 25 to 34. So these are groups, okay? And so far they are categorized and they have ranking inside them. Then we said that the measure, that's the scale, that what we choose here is ordinal because they have a ranking in between them. But then if they are categorized and there is no ranking and they are not numbers, then we said that we choose nominal here, okay? So we said, we gave the rules for entering data here. I said to keep things simple, I just enter question 1, question 2, up to the end, up to the last question. And then that's for the ID, okay? To keep things simple. And then we said that under the label, you copy in the questions. So if I expand this thing now, you see that these are the questions. Question 1 to 2, up to the last question, 41. Okay, so you put in all the questions here inside the label. You can use Excel to put it, and then you copy it and then paste it inside here. All right, then we now say that to code the options on your questionnaire, you go to these values here, this column called values here. So this is where you enter the options. So we said you can choose any number that you want, whether you want to start from 1 or you want to start from 0. So we use 0 for here. I did here, I put 0, 0. Then I typed in the option. The option is female. So then I clicked on OK. So that's how we did that. And then I also did for male. So that's how we did all these questionnaires here. So you can see the option here. He will use 1 for Christianity, 2 for Muslim, and 3 for traditional. So once you have entered the ID, which is this first column called name, then you enter the data type, whether it's a number or is it a variable. Okay, so and then you enter you copy in the questions, then you enter the options inside here, and then most importantly, you choose the scale, the type of scale. If it's a pure number that is not grouped, you choose scale. If it is a number that is grouped together that has ranking, then you choose ordinal. If it's a letter, then you choose nominal. So that's just a brief recap. So this is how to code in your questionnaire. And then we said that when the question is when it is multiple response questions. I can't find that questionnaire again, but okay. David, if you can just share the questionnaire on the group, on the chat, that would be fine, so I can download it. So
I should share the questionnaire.
Yeah. Maybe either on the WhatsApp group
I should send it again.
Yeah, so I can download this from my laptop. So
okay, let me share it again to them.
Yeah. So then we said that for multiple response questions, that means the one that you can tick more than one options, that you don't code them the way we coded these ones here. So rather, each of those options will become a new variable. So like this is number 28. You can see is a multiple response question. That is, has multiple choice. You can select more than one. So we coded them as 111 variables here. And then we said that the data, when you go to the data view is a view where you enter the responses of, that's where you enter the responses of your participants. And then we said that this data, in this data view, you have this box here, 1A, 1 to A and A to 1. So if I click on it, it will change, and then I will see the options here. Okay. So, but how we coded them, remember we said that 1, we said something like here now, we said 1 is aware and 0 is not aware. So if you check it, you see. So anything you see, anywhere you see 1 here, you see that these are all aware, aware, aware. 0 is unaware. Okay, that's how we coded it. Okay, so if you want to see the value, the labels, you just click on it again. So now I said for multiple response questions, like I said before, multiple response questions, those number 28. So remember we created these, each of them as a variable. That's the options as a variable here. So if somebody ticks indoor residual spraying, that will become 1. If participants, okay, here participant 1 did not tick indoor residual spraying, so we coded it as 0. But here, he or she ticks use of insecticide treatedness, so we coded it as 1. So if you want to see the values, just click on this. Okay, for now, you will not see anything here because this is a multiple response question. So, but we all know that 0 means the person did not tick it, and then 1 means the person ticked it. Okay, and then how you analyze multiple response variables is different from the way you analyze the others. So this is basically what we said. So I think the video is available later. You can watch it to recap. So all right, so let's go ahead for today's session. So we stopped at Likert scale, and we said Likert scale is the scale that has ranking, is an ordinal scale. It has ranking like I agree, strongly agree, all those kind of scales. So we are trying to see okay, so okay, let me recap the Excel part. So we stopped somewhere here. We said once you have gotten all your values from your Likert scale here. Sorry, let me get the questionnaire so that I can download it. Just a minute. So what's the name of the group again? APSO. Yeah. Okay. So this is the questionnaire, and then we said that what a multiple what we're trying to analyze is this Likert scale here, this one that is strongly agree. So that's what we want to analyze, which we started yesterday. So this is the scale that we're trying to analyze, and we used SPSS to generate all the values here. And what I was saying that was that once you have filled this table, the 16 is the frequency, and then the percentages are in the bracket. So we said that for you to know which one to use to summarize this Likert scale, whether to use mean or to use median. So we said that you need to check for normality. So you need to check if the Likert scale is normally distributed. Okay, so that's what we said. And then we said that to check for normality, you use, you just click on analyze, go to explore, and then I'll just move back all this. So we said you move in those variables there inside that place. So these are the variables here. Where the attitude, let me just take, that is number, question number, what is it again? That's question number 20 to 26. So we said we move those variables into this place, and then we select the plots. We want normality plots, basically, and histogram. So normality plots and histogram, basically, that's what we want. So you click on continue, and then click on OK. So SPSS will now analyze it to give us the response. So we said that to check for normality, you look at the QQ plot. There are different ways to check for normality, but the easiest one is the QQ plot. Okay, so if you look at it now, you see that the variables are very close to the line, okay, to the normality line. They are not scattered, they are not one-sided. So they are very close to the line. And that is one way to say that, okay, our data is normally distributed. And if it is normally distributed, then you can use mean. Instead of median, you use mean to summarize your Likert scale. Also, you can also see your box plot here. You see that is not, there are no extreme tails. That means there are no outliers. If there are outliers, you will see them as dots. That means like there are no extreme values on both ends. Okay, and then we said that another way to look at normality is to check for the cogmoro, what's it called now? That's one test there. Okay, yeah. Okay, so you can this Kolmogorov test, Kolmogorov and Shapriko. So now, and this test here, if they are significant, then that means that your data is not normally distributed. Okay, and then if you can easily confirm that using your QQ plot. So from here, you see that the data are very, very close to the straight line, and they are normally distributed. And then that means that we can go ahead with our mean. We can use the mean to summarize. And then we said that to use the mean, we extracted all the means and standard deviation from the SPSS, and we put them here. And then we said that there are two ways that people normally do this. The first way, which is normal, which you see in publications, is that this 5-point scale is divided into 5 groups. Okay, so we assume that anything between 1 to 1.8 is strongly disagree, and then anything between 1.81 to 2.6 is disagree, 2.61 to 3.4 is undecided, 3.41 to 4.2 is agree, and then 4.2 to 5 is strongly agree. Okay, so then based on this, you can now categorize all this based on the mean score. Okay, you can now categorize it. So that is one way of doing it. You can now make your decision. So like this 1.49 now, if you're using that method, 1.49 will fall under strongly disagree, right? So you can now say in your research that most of the participants did not, they showed strong disagreement that malaria program prevention patterns are effective. So that means they strongly disagree. based on the, so that's how you interpret that. So depending on the where the mean falls, you can now put in your decision here. So that's one way of doing it. Now, the other way of doing it is to take into consideration the opinions of that means the data sets that you are using. So you use weighted average, which I think that one is okay for me. I prefer that one. So use the weighted average because I'm not just basing my decision on arbitrary categories like this. So, and for you to do the weighted average, we said you add up all the means together. You can use calculator or you can use Excel to add up all these means together. So for me to add them up, I did just equal to, press equal to, then click on sum. Then open the bracket, select the variables, hold down your shift key, and then go up. And then close your bracket. Okay, so you can see that this is the total of the mean scores, and then we counted the number of variables on the Likert scale. There are 7 variables here, so we now did 20 divided by 20.4 divided by 7. That will give us 2.91, and then we use this as our cutoff mark. Okay, and normally if you're using this method, you have two-sided decision, either good or bad, for favorable or unfavorable, low perception or high perception. So based on that, anything that is below 2.91, I will say that because this is below 2.91, so that's many of the participants showed an unfavorable attitude towards malaria program prevention. They had a very negative perception about the effectiveness of malaria prevention programs. Okay, so if they are above 2.91, then I will say that they have a very favorable, they have a very good attitude towards malaria prevention program. Okay, so that's how you make your decision, and then you now write up. You now do your discussions. Okay, so this is what we said yesterday. Okay, so now the question that I want to ask now is, if you want to now know if your research question says that, okay, does the attitude, is there any difference between the attitude of males? Does gender influence the attitude? So now this one, what you have now is the combined scores. That means you have combined all the means for all the questions to get this one. So now, is there any effect of gender? How will you approach that? So now that you have the combined values, is there any effect on gender? So now we need to put in the cumulative, that's the combined mean inside SPSS. So you can, if you have a paper, you can jot, if you have something to jot, and jot at this point. So let's see how we can turn our responses to have a single mean. I mean, how we can do this thing now using SPSS. So what we're going to do now is to generate a combined attitude score. Okay, so let's see. Well, how will you do it? So the menu for that is called transform. So transform, anytime you want to generate new variables or modify existing variables, then you remember there's a menu that's called transform in SPSS. Okay, so now I'm going to click on transform. That's step 1. Now, what I want to do is that I want to generate the mean. I mean, I want to generate a single unit, a single variable that will show me the attitude for this Likert scale. I mean, these particular questions. So remember that we are working with 50 participants. So I want to get a single column that shows the mean scores for all of them inside SPSS. Okay, so how are you going to do that? So in other words, I want to get something that looks like this. You see this mean here? You can see that, you know that we copy this 1, 1, 1, 1, and then we put it inside Excel. So I want to get it something like that in SPSS. So how you do that is you go to transform. Because it's a calculation, anything that has to do with calculation, you want to compute, okay? So you click on compute, that means to calculate something. In SPSS, use transform, and then compute variable, you click on it. Now I want to name my variable, okay? So my variable is mean underscore Likert. So I want to just get the mean. Since I've decided that it's the mean that I want to use, I want to get the mean. So I give it a name, and then I'll now, so now then I need to select a function here. So I'll click on it and then scroll down to where there is statistics, where I will see statistical, okay? So I'll click on it. So first of all, I just gave it a name, any name I like, okay? I'll give it a name. Then I select statistical here. Then now, do I want to compute the mean or the median? I want to compute only the mean because my data is normally distributed, okay? So I want to compute the mean. So I'll click on mean, I'll click on it. So once you double click on it, you can see it will appear here. Okay, so now it's asking me to, you can see there's question mark, comma, question mark. So it's giving me an idea on how I can how I can put in all the variables. So I have to separate them with question mark. Okay. So I'll now go back to my questionnaire. So my questionnaire is from number 20 to number 26. So we want to get the mean. Okay. So now, remember, I've already added all my numbers here. So I'll go to question 20 to 26. So this is question 20. Then I'll hold down my control key, 21. Okay, sorry, should be 1, 1. So click on this one, on the arrow, and then put in a comma. Click on 21, put in a comma. See that? Then 22, click on the arrow to move it, and then put in a comma. 23, click on the arrow to move it, then put in a comma. 24, click on the arrow to move it, put your comma. 25, move it in, and then put your comma. Then 26, move it in, and then put your comma. So you can see. So now that I've put everything inside here, remember that I've given my variable a new name, mean of the Likert scale, okay? Mean, or I can say mean attitude for me. So I will know ATT, mean attitude. So once I'm done, I'll click on what? Okay. It's saying the sequence of operators, check the expression for omitted or extra. Okay. Oh, sorry. So you can see that there's a comma here. So I have to remove it. There's a comma after number 26. Okay, so now I've removed it. So I click on OK. So now, if I go back to my data view, this is the data view here. I will see a new variable. If I scroll down to the end, you see that? So I've seen a new variable here that is giving me the mean of all those attitudes in a single column. Can you see that? So for all the participants now, I have the mean scores here, okay? If you want to do the median, so it's the same way I did this one. If the data is not normally distributed, the same thing again, you can just go to, again, transform, compute variables. Now I will now say median, okay? Median attitude. Then here, I'm going to, I will now click on statistics. I will now search until I get to statistical, and then I'll select median. I'll double click on it. So double click on it. It will now give me median. See that? So I'm going to remove this one again. And then I'll do the same thing again. So I have it already here. So question 20 to question 26. Then I'll click on what? Okay. You see that? Then I'll close this output. No, I'm not saving it, so just close. Then if I go back to my data view, that's this one here. You can see the median attitude here, all the scores here, the median. So if your data is not normally distributed, you can use this. You can do your mean and then median, and then you can still test for your normality too on them. And then if it's not normally distributed, use median. If it's normally distributed, use mean. Okay. So our data is normally distributed, so I'm going to use mean. So now I have a single column that contains all the mean score. If I go back to my variable view in my questionnaire, you see that it created another variable here, inside here. That's mean attitude, median attitude, and mean attitude. But the one I'm using is what? Mean attitude. So now I want to know, does the mean attitude of my respondents vary by gender? So now my label, I'll just add this and say mean attitude. Okay. Then this one is median attitude. Median attitude. So now that I want to know, does my attitude vary by gender? Does the attitude towards malaria program vary by gender? So for us to do that, you remember that our gender is a categorical variable, right? If you watch, it's only male and female. Okay. Now our mean score is a numeric variable. Is a numeric variable. If you watch, they're all numbers. Okay, they have points. They're all numbers, and there is no grouping inside them. All right. So now the rule is when you have a categorical variable, and then you are comparing it to a numeric scale. What kind of test can you use in this situation? What's the best test that you can use? You have a categorical variable, that's male and female, and then you want to analyze it, you want to compare it, you want to do an analysis, and the other scale is just numbers. So the best test that you can use here, categorical and numerical, is what? You use a one sample t-test. A one sample t-test. Okay, so one sample t-test compares. You remember that we are assuming that the groups there is no relationship between this male and female. So there are two independent groups. Okay, two independent groups, and then the outcome variable, the outcome is attitude score, which is what we have generated. So we have generated an attitude score, mean attitude. So we want to say, does the mean attitude vary by being a male or female? So, and the best test that you can use for that kind of question is your one sample t-test, okay? So let us do that. So if you go to analyze, we will now go to compare means. So remember the last time we did frequency, descriptive, explore. I don't know whether we did cross tabulation, but these are the ones you have to know. At least you have to know them, these first four. Okay. So now we are going to the next one, compare means. So I'm going to go to compare means. Sorry, it's not a one sample t-test. It's an independent sample t-test. It's a mistake, independent sample, because these are two different samples. Male is a different sample from female. So it's a two sample t-test. Then we'll come back to one sample. Then I will show you how to do that. So this is a two sample because there are two different samples, and the male does not depend on the female. There is no relationship between the male and female in this sample. So we prefer to use a two sample t-test. But when can you use a one sample t-test? The same thing again. You can use a one sample t-test when you have a one sample, okay, measured twice. Measured twice. Okay, and then versus the outcome is a numerical variable, a numerical scale. Numerical scale. That means a number. So when you say, like, if you're doing chemistry experiments before and after, so you measure the fasting blood glucose before, okay? Let's say for a group of women, you measured their fasting blood sugar before and after intervention. So you have two columns, before, and then you have after. Then you enter all the numbers, okay? You enter your, let's say you have 10 participants, before and after, because you are using the same sample. And the sample was measured twice. So when you're using a before-after study, and then you want to look at the effect on weight loss. So this here, this numerical scale is weight, and weight is measured in kg, right? And weight is a number. Okay, so you're comparing the before and after values to know the impact on weight. So if you have this kind of study now, the kind of test that you need to run is a dependent sample t-test. I've also made another mistake again. So it's a dependent sample t-test that you need to use. So let me come again. When you have two categorical variables and they are independent, there is no relationship between them, you use an independent two sample t-test. Independent, that means there is no relationship. It's not a before-after study, okay? Because there is no relationship between the male and female. And then the outcome is numeric. So you use an independent two sample t-test. Now, when you're using the same sample and you are measuring them two times, that means that there is a dependency because it's the same population. Then you use dependent two sample t-test. Remember, you are measuring them two times, and the outcome variable is numeric too. It's still numeric, it's a number. For example, weight. So if you're comparing the impact of the effect of taking maybe taking let's say taking an anti-diabetic drug. Okay, so you are comparing the levels in the blood. You're comparing like the fasting blood sugar before you took the drug, and then the fasting blood sugar after you took the drug. All the samples are coming from the same. All the blood samples are coming from the same subjects. So this is a dependent two sample t-test. Now the last category is when do you now use one sample t-test? So when you use one sample t-test is when you are comparing the average value, 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 the average value in your sample, you are comparing it to a reference population. So what I mean by a reference population is, for example, if they say that in Nigeria that the average weight of an obese adult in Nigeria is 90 kg, for example. Now you want to now compare the average that you got from your own research to that 90 kg. So you want to check whether does your own the results you got from your own average, is it different from that of the standard population? Is it different from a reference population? So that's when you use one sample t-test, okay, in a very simple way. So we're going to demonstrate all these things now in this questionnaire. So let's go back. So now we have our mean attitude. So we want to now compare, does the mean attitude vary based on gender? And like I said before, since we have mean attitude and there is no dependence between the two samples, men and female, so we're going to use independent two-sample t-test. And also the outcome is a number, is numeric. Remember, what we are measuring is a score, and that score is a number, mean attitude. So for t-test, your outcome must be a number. You cannot do, if you have categorical versus categorical, then it will change. Okay, so what you're comparing must be a categorical variable and then a numeric outcome, a numeric scale for you to use t-test. So now we're going to use the t-test. So now let's do that. So I said you go to analyze, go to compare means. Okay. Now which one are we going to choose? We will choose independent because male and female, and there's no relationship between them. Okay, they are not dependent. And then the outcome is a number. So we use independent sample t-test. Now we are going to now look for that mean attitude score. Mean attitude. It starts this one. So we move it inside the test variable. And then the next one is, we'll now say what is the grouping variable? We want to select gender. So you select gender. You select gender, and then you click on this arrow here to move it inside the grouping variable. And then you will now see this question mark here means that you have to define the groups. And if you remember, in the SPSS, we coded women as 0, right? And men as 1. So I'm going to click on define groups. So you enter 0 here for group 1, that's women, and then 1 for group for males. And then you click on continue. And then you click on let's see if there's anything. So your confidence interval is 95% already. So click on continue and then click OK. Once you do that, you will now see so this is your t-test. So this is where you have to pay attention. So now we see that the mean for the males are, sorry, the mean for the males are higher than the mean for the mean attitude score for the females. All right. So now the question is, does this mean is this a significant? Is it really significant? Okay. Yes, we know that men have more favorable attitude towards the malaria prevention program than women based on this. But then, is it significant? So that's the question. So now in t-test, there are two types. So sorry, there's what we call the Levene's test for equality of variances. So what we do here is that if this, you can see that SPSS gave us the mean attitude score when you say equal variances assumed, and then you have equal variances not assumed. So you check this first one here. When you see SIG, that's significant, two-tailed. Now, when you say something is significant, when the p-value is what? Less than, when the p-value is less than 0.05. So if your p-value is less than 0.05, that's 5%, then you will say that it is what? Statistically significant, okay? But if the p-value is more than 0.05, then you will say that it is not statistically significant, okay? So now, what do you do when the p-value is less than 0.05? That means it is statistically significant. What you would do is to do what? Is to I will just say, you don't say this, but to make you to understand this, you say you accept, sorry, you say you reject the null hypothesis, okay? Now, but if it is above 0.05, you say, you say accept, okay? But in academics, you don't accept null hypothesis. But for you to understand it, you say you accept the null hypothesis, okay? But when you're writing it in your what you write is that you fail to reject null. So that's the way to write it. So when the p-value is more than 0.05, you fail to reject. So when you fail to reject the null hypothesis, that means indirectly you are accepting it, okay? But you don't use that word accept because there are a lot of controversies around this. So you just say you fail to reject it. So what is p-value? P-value is the probability that the result of your research is due to chance. Okay, so now you can see that here, the p-value is very, very small, only 5% here. So that means that your research is not due to chance. The results of your finding is not due to chance, okay? There is only 5% probability that it is due to chance. So that means that it's very, very small. So if your p-value is very, very small, less than 5%, you reject the null hypothesis. So the null hypothesis says that the result of your finding is due to chance, is the probability that the result of your finding is due to chance. So here, we are saying that the probability of our finding being due to chance is very, very small. It's just less than 5%. Okay, so we have to reject that null. All right, but if it is more than 5%, if the probability of your finding being due to chance is more than 5%, then you fail to reject the null. That means that the null is true. Okay, that means that the probability of your finding being due to chance is high, is more than 5%. You see that? So this is just like, in case you don't understand p-value. So let's go back to our SPSS. So here, these are the Levene's test for equality of variances. You can see that this p-value here, you can see this t-test for equality of mean. So now this our p-value here is more than 0.05. Is more than 0.05. So that means it is above 0.05, right? So if it is above, then if it's above 0.05, then I'm going to use this, I'm going to use the upper row, and the upper row is that the row that has equal variances assumed. So the p-value I'm going to report is 0.267. The p-value I'm going to report is 0.267 because the Levene's test of equality is not significant. Look at this one. So this Levene's test of equality of variances is 0.558, okay, which is above 0.05. So it is not significant, okay. And if it is not significant, you report the p-value for the first row. So let me repeat what I'm saying. What I'm saying is this, that in t-tests, you have to first of all interpret the Levene's test of equal variances. Now, if this Levene's test is above 0.05, you will use the first row. You use the p-value of the first row. Okay? Now, if the Levene's test of equality of variance, if it is below 0.05, then you use the p-value of the second row. Okay? So you can see above 0.05, you use the first row. That's the above row. Okay? Simple code. Below 0.05, you use the second row, which is what the row below. So let's look at it here in our SPSS. So here, our Levene's test, if you look at this, our sig value here, this is the sig value here. You can see that our Levene's test, the p-value is 0.558, which is above 0.05. Okay, so that means that the p-value of our t-test, the one that we choose, is what? 0.267. That's the first row. So if we are reporting our t-test now, the one that we're going to report is, we want to report this our p-value here, this first row. That's the one that's what we're going to report. And this is our confidence interval. Let me show you. This is our confidence interval here for our t-test. So this is the confidence in the interval here from minus 0.531652 to 0.15070. So this is the confidence interval, and this is the mean difference. So remember that we coded our females as 0 and men as 1, and here we have a minus. So this minus, how we get it is when you do female minus male, when you do the mean, 2.8381 minus 3.0286, that will give you minus 0.19048. So that's how we got the mean difference. So that means this minus here is because the average attitude, the mean attitude for females is actually lower than that of males. Okay, so the rule in interpreting your t-test is, number one is to what? Look at the Levene's test of equality of variance. If the significant value is above 0.05, you maintain the first row. You use the first row. If the Levene's test of equality of variance is less than 0.05, if assuming that this is 0.001, then the p-value that we're going to interpret is what? The row below, which is what? 0.258, which is still not significant. Okay, so that's how to interpret. That's how you can interpret your t-test. Okay, so our finding here is that although the average attitude of males towards the malaria prevention program, that males have a higher favorite, they have more favorable attitude than women. However, this finding is not statistically significant. Okay, in brackets, p-value is equal to 0.267. Then our confidence interval is what? Is it minus 0.53165 to 0.15070. So that's how you interpret your t-test for independent sample. Your independent two-sample t-test. Okay. Now we go to the next one. So assuming that you are doing a before and after study. A before and after study. And that means a study that you, so let me open a new one. So let's say that in this study now, like I said, you tested the fasting blood sugar before an intervention, and then you tested the fasting blood sugar after the intervention. Okay, so let's say your intervention is sharing free anti-diabetic drugs to people in rural areas that cannot that don't have access to it. And then what your outcome measure, you are looking at the effect on weight. How is the drug effective? Okay, so now, so let's say you measure the fasting blood sugar, and then you have got some values. So let me just generate some values here, like equal to rand between. So I'll just generate 0.0. Okay, let's say random blood sugar. Okay, let's say like from 50, and then okay, let's say it's from 50 to 140. So now I have my random blood sugar for 20 participants, and then I have the one for after. So remember, here is FBS, fasting blood sugar before the intervention, and then your fasting blood sugar after the intervention. Okay. Okay. So now, so you want to check, you want to compare these two variables. You want to compare them to know the impact on weight. So let's say their weight is maybe from 50 to 90. So we have like something like around between 50 and 90. Okay. So I'm going to get just, oh, sorry, between 50 and 90. So you want to look at the effect, the effect on sorry, this should be a categorical variable. So let's say this is income. Okay, let's say that this is gender. Okay, let's just use gender because it should be a categorical variable. So we have male and female. So female is 0 and then male is 1. So let's just put it like that. So we have rand between 0 and 1. So like I said, in t-tests, one variable is categorical, and then the other variable is numerical. Okay. So now we have gender here, and then we have fasting blood sugar. So we want to now see how best we can use this in our t-tests. So I'm going to just copy all these things, and then I'm going to put them inside the SPSS. So we have, I'll create a new variable now. Under variable view, I'm going to create a new variable. So we have fasting blood sugar, FBS before, okay? And then we have FBS after. All right, so this is fasting blood sugar before, and then fasting blood sugar after. And then already our male and female is up there. So we already have the values. Now I'm going to go back to my data view to enter all this before and after here, scores. So I will now go to copy it from Excel. So I have 50 variables already. So I'm going to make this in up to 50, so it will match my variables. So I have 50. So I have 50 variables. I think it should be 54. Yeah, I have 50 variables now. Then I'm going to copy everything. Ctrl C, and then go back to my SPSS, the data view, and then I'll paste my data. All right. So now these are the scores before and after. Okay. So now I'm going to run the dependent sample t-test. So here I'll now say analyze again, the same place I went before, compare means. Now I'm going to select paired sample. Compare means. Now I'm going to select paired sample. Okay. So I'll select paired sample. The paired sample is something as dependent. Paired sample t-test. Now it's asking me for the first pair. What's variable 1 and what's variable 2? So variable 1 is the before. I'll click on it and then move it in. Then it's asking me what is variable 2. Variable 2 is the second variable, that's the after. Okay. Then click on options. My confidence level is still 95%. Continue. And then I'll click OK. Okay. So now, I want to find out whether my intervention is there any effect? Is there any significant difference that my intervention made? Okay, so is it of any value? So here you will see that our mean, the mean for the before and after, they are very close, right? So there is no much difference. Anyway, so but even though that it seemed that giving the anti-diabetic drug reduced the average fasting blood sugar by, it reduced it by, where's our mean difference? It reduced it by, where's my mean difference here? 99.24 minus 97. So let's say it reduces it by 2 on the average, but that's a very, very small difference, okay? So now let's check our confidence, our the test itself. Let's see what we have. So here you can see these are our mean. That's fasting blood sugar before minus fasting blood sugar after. So our intervention reduced the fasting blood sugar by 1.98 units on the average. So we'll now check our p-value, whether our p-value is it significant. So if you come here, you see that our p-value is 0. Here, that's here. Our p-value is 0.728. 0.728. So that means it's above 0.05. And remember, we said that if the p-value is less than, if it's very, very small, less than 0.05, we reject the null hypothesis. But if it is more than 0.05, we what? We fail to reject. That means indirectly we accept, but you don't say accept. So we fail to reject. So here, because our p-value is more than 0.05, which is here is 0.728. So we fail to reject the null hypothesis. So that means that there is probability that our findings are due to chance. Okay, so that means in other words, our intervention was not effective. Okay, it was not effective, even though that the mean fasting blood sugar reduced by 1.98 units. But this small difference is not statistically significant. And then our confidence interval is from minus 9.414 to 13.374. Our confidence interval is too wide. Okay, and when it is too wide, you can see that it moves from minus to plus. So that means it crossed the midline. It crossed 0. So once your confidence interval crosses 0, it means that your findings are not statistically significant. Okay, your confidence interval is too wide. So when I say crossing 0, I mean like you have -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. You can up to 13. So you can see that it's very, very wide confidence interval. So that's another thing that you can use to know that your findings are not statistically significant. Okay, so that is for per sample. So basically, in per sample t-test, what we actually need is just the first 2 samples. You don't need the gender here. This gender I'm doing here, you don't need it. You just need the before and the after. So you are comparing their averages to see if there is any significant difference between the 2 groups. Now, the last one that I want to do is the one sample t-test. So one sample t-test. So let's say that the average, for one sample t-test, let's say that the average satisfaction, okay, let's say that the average satisfaction score is, where's my satisfaction score? So I created a new variable that's called satisfaction score in SPSS, okay? I just put it just to demonstrate it. Okay, so I created a new variable that's called satisfaction score here. So let's say like when you want to check how satisfied are you, okay, of maybe based on your intervention. So you want to rate their satisfaction over 10. And then I have 50 participants here, okay? So what I did was to just copy out this whole satisfaction rating. There are 50 participants. I told them to rate their satisfaction of our services. So I copied it, and then I went into my SPSS. I created a new variable here, and I named it what? Satisfaction. Satisfaction. Okay, let's just say 1. Okay, and this my variable is what? Satisfaction. How satisfied are you of our services? So how satisfied are you about our services? Our services. So that's the question. And then I told them to rate it 1 to 10. Okay. So that's the question. Now the scale we are using here is what? A number. So we're using scale. Okay. So, and then they now give me their answers. Okay. Now I'm going to enter the answers inside the data view. I told you variable view is for the questionnaire. The data view is to enter what? The responses. So now I have the responses. I'm going to enter them here. Here, they're empty. So I'm going to just go to my Excel and copy it. Copy what I have. Control C. This is my Excel. I'll just copy them and then go back to my SPSS and then paste all of them. Okay. So now I'm going to do an analysis to see if, remember, let's say that in Bradford, the average satisfaction score, research has shown that the average satisfaction score after intervention for diabetes in rural areas is, let's say, is 70, is a 7 over 10. Okay, now I need to now say, okay, is my finding the same as what we get in the national data, which is what? Reference population. So if you remember here we said that one sample t-test, you are comparing the average in your sample versus what? That of a reference population. So I want to compare my average satisfaction score to the satisfaction score for Bradford as a whole. So I'm going to go back to analyze, compare means, go to, now I'm going to use one sample t-test. That's where I'll use it. So one sample t-test. Then I'm going to go back, scroll down to the last one where the new variable I So it said, how satisfied are you? So I'm going to click on it and then click this arrow, move it to this place, go to options, and then make sure that this is 95% confidence interval. Then click on OK. Okay. Sorry, I missed something. Go to analyze, compare means, one sample t-test, then enter this, go back, ensure that this is 95%, and then test value. So I said that the average satisfaction score in Bradford after an intervention for diabetes is 70%, is 7. Is 7. That is what research have shown. So you want to compare your own research to that of a reference population. So that's why I put 7 here. So I'm going to click OK. So you can see that one sample you're comparing the average of your data to a specific number, to that of a reference population. So here we have that the mean of our sample, so here we have that our mean satisfaction score is 5.0600. So 5.06 generally. That's the mean, and this is the standard deviation. Okay, and this is standard error. So let's see whether our own do we have. So you can see here the difference. Our p-value here is what is significant. Okay, is significant. So that means that our average mean is lower from our own research. The satisfaction level that we got on the average is lower than that of Bradford or that of Nigeria. And this is a significant finding. It's very significant because this is 0.000. So this is less than 0.05. So remember what I said, that if your p-value is less than 0.05, what do? That means it is what? Significant, and you reject the null hypothesis. So the null hypothesis says that everything you are doing is due to chance. That's what the null normally say. The average, the average, that's your research, everything is just due to chance. Okay, there is no impact of intervention. So, but here, because our p-value is very, very small, it's 0.00, we will now say that our research is what? Statistically significant. Therefore, we reject the null hypothesis. See that? So based on this, I can say that my research is what? That's my findings are statistically significant, that this group of people are less satisfied about their services compared to the national average of what? 7. And that will prompt what? An intervention. That will not cause you can now present this, and maybe that will be the reason to do further intervention for those group of people. So that is how you do it. So let's say if you're working in the HIV program for key population, let's say that the access to HIV drugs for Imo State, on the average, if you give them a questionnaire and then tell them to rate their access, how accessible do they have drugs for members of the key population, like those let's say like prisoners, they are at more risk. Okay, so you now compare, you now check published articles to know what is the average average score for accessibility to HIV drugs in Nigeria as a whole, or in Imo State. So if you're doing it in a village, you can use Imo State, or in Nigeria, then you get that average score and then compare it to your own score. So that's what one sample t-test is about. All right. And then the last one before we now have questions is, what do you now do when your variables are all categorical? So That's where that's where we'll stop. So what do you do? How do you, what test can you use for categorical variables? When I say categorical variables, I mean if you have gender. Oh my God, what's going on? This is not working again. Okay, so if you have, oh, it's not working. Okay, if you want to compare gender versus okay, let's use the questionnaire. There should be one that we can use inside this questionnaire. So variable view. So let's say you want to now compare want to get two independent variables. So you want to compare, is there a relationship between education level and attitude, and let's say an attitude, education level and what can we use here now? I want two categorical variables. I'm going to use, is there a, or can I just illustrate what I mean? Okay, I'm going to use the Likert scale. The Likert scale has 5 categories. That's number 20 to number 26. So now I want to now check if is there a significant difference based on education level. Does education level affect our attitude towards malaria program prevention? So that's the question. So now when you have two categorical variables, education level, and then versus attitude, okay? So remember, the attitude, you have already categorized it as what? You have already categorized your attitude already. So now, is there a relationship between education level and then attitude to malaria programs? So now we are going to look at the attitude now. So you remember that we said that our attitude is, for now, you can see that our attitude is still like a number. You can see it's still like a number, the mean attitude, okay? All right, our attitude is here, is still like a number, the mean attitude here. So now what we're going to do is we're going to convert this, our attitude that is a number, we're going to convert it into a categorical variable. Okay, so now based on what I said before, we said that based on our weighted mean, we said that any mean that is above 2.91 is high attitude. Abi? That's what we said. Any mean that is above 2.91 here is any mean that is above 2.91 is a good attitude, that's favorable attitude. And then any mean that is less than 2.91 is what? Unfavorable attitude or poor attitude. Okay, so that is based on our decision. Now we want to group all the standard all the mean attitude scores so that we can get a categorical variable. So, and that is exactly what we want to do now. And I said that anytime you want to do any kind of stuff, you go to what? This menu that is called transform. Okay, so now we're going to just group this mean attitude score so that they will have groups. So now I'm going to go to transform. Now I'm going to say recode into different variables. because I want to create a new variable based on this, my mean attitude. I want to group them, I want to categorize them into low attitude, as poor attitude, or unfavorable attitude, and then favorable attitude. I want to categorize this mean scores. All right. And that's why we need to do what? Go use this our transform again. Okay. Now, for us to use the transform, you click on this transform, go to recode into different variables. Recode into different variables. So what do you want to recode? I want to recode my mean. I want to recode my mean attitude. My mean attitude, that's this one. Okay. I want to recode it. You recode it into what? So now the name. So I'm going to give this attitude category. Okay. That's what I will name it, attitude category. So label is attitude category. Remember that in your label you can give space, but in your name there is no space. If you remember the rules of SPSS, you don't give space, and you don't use some symbols like dollar, question mark, and stuff like that. Okay. So label is just like the normal question. So that's why. So I'm going to click on change. Okay. Now I'm going to say click on this old new values. Now I will now say range. Okay. And now the range is that anything from 0 to 2.90. That's 2.90. Anything from 0 to 2.90, I will categorize them as, I'll click on this output variables. I'll categorize this one as, just check here. Then I'm going to categorize this as unfavorable attitude. So why I click on this is because I want to type in a letter. So output variables are strings. I want to type in a letter. So if I remove it, you can't type in a letter here. You have to type in a number. Okay. So but I want to type in a letter, so I'm going to click on it and then type in unfavorable attitude. Okay. Add. Now anything from 2 points, then I'll click on range. Anything from 2.91 to 5.0. I'll categorize it as what? Favorable attitude. Click on add and then click on continue. Okay, you see that? Then click on OK. Based on this, we have generated a new variable in our SPSS. I'm going to close this again. So let's check. Can you see that we have unfavorable? Well, based on our mean attitude now, we have categorized them now. We have divided them into unfavorable and favorable, right? And by doing this, we have met the criteria for what? Using a chi-test. We have met the criteria for using either you use a chi-square test, or you also call it cross tabulation. All right. So because we are dealing with two categorical variables, education level has categories inside it. All right. And then attitude has categories inside it. So we can use a chi-square test, okay? Or cross tabulation. All right. So for us to do that, remember that our variable name is, our new variable is what? Attitude category. And we have two different categories. You can see all the variables here. So now we're going to go to what? Analyze again. Now we're going to go back again, go to our descriptive statistics, and then use cross tabulation. Okay, cross tabulation. So once you click on cross tabulation, you will now go back to select your variables. Okay. So on the rows, I will select my attitude category. Okay. And then, so I want to know whether my attitude category varies by education level. So I'm going to select education level in the next one. Where's my education? That's question number 7, right? Education level. So I will select it. And then I'll click on statistics. I want my chi-square. I think that's the only thing that is important here. I want my chi-square here. All right. Then click on continue. Let me see whether is there any other thing again. Nothing else. Nothing else here. Sales counts. Do I need counts? Okay. All right. So that's good. Just leave it the way it is. Do I need percentage again? Let me see. Do I need anything again? Percentages. Okay, I can just select row. Or let me just keep it simple. All right. So I don't need any other thing again apart from my chi-square test. So I can say display cluster bar chart if I want. Then click on OK. So that is your cross tabulation or your chi-square test. So now you can see that education level, we have no formal education, primary, secondary, and tertiary, right? Okay, so now let's look at our chi-square test, whether it is significant. So these are Pearson chi-square tests. You can look at this is 0.247. So our chi-square value is not significant. It is not significant. Okay, our chi-square value is not significant. So because it is not significant, based on what we already know now, when the p-value is above 0.05, what do? You fail to reject the null hypothesis. So that means that what? There is no statistically significant association between gender and what? The attitude. Sorry, there's no statistically significant education level and attitude to malaria program. All right. So this is the bar chart now. Now, so from this bar chart, you will see that. Let me see whether I'll get any other stuff. So from this bar charts, you will see that this pink, this dark blue here is no formal education, and then the purple here is tertiary. So it seems like those that went to school, those in university, and those without formal education, all of them, two of them, they have unfavorable attitude more. You see that? Okay, so now, and one category is, so they have more unfavorable attitude here among the, let me see whether there is a label. There should be a label because one of these should be for male and another one should be for female. So those that didn't go to school here, they have more unfavorable attitude towards malaria prevention program. So that's what my bar chart that's what I can see. So now here that I'm not seeing any percentage yet because I didn't select it. So let me do it again, add the percentage. So I'm recapping. So what I did was to go to analyze, descriptive statistics, cross tabulation. So whenever you're doing chi-square test, that you use cross tabulation. So cross tabulation, and then I put in my attitude category. Let me go back again. So what I did was select my attitude category. Okay, I can put them on the rows and then select my education level on the column. Then click on my statistics. I want my chi-square. I think that's the only thing I need now. Then click on continue. Go to sales. Now I can add my percentages if I want. I can add my percentage this time around. then and then click OK. All right. So now based on this now, you can see that you have your percentages here. So among those that don't have formal education, 16.7% of them have a favorable attitude. Just so very few of them have a favorable attitude towards malaria program. So you can do your write-up by showing all these percentages here. Okay, and then still the most important thing is our chi-square test. You can see that here our chi-square is not significant. Okay, so that means that there is no association between education level and attitude. So in summary, what we have done today is to do what? How to turn your Likert scale from numbers, and I mean how to get the mean score or the median score for your Likert scale, and then how to use that mean or median score how to turn that mean score into a category, and then use that for chi-square test. All right. So David, I think I'll stop here. I don't want us to do 2 hours again. All right. My time is finished. So David, can you allow people to talk now and ask questions so that we can close for the day? Hello, David. Hello, David. Are you there? Hello. Can anyone unmute the mic, please? David, are you there?
Yes, Tony, we can follow you.
Okay, so I'm done. Can you allow people to ask questions now? Can you allow people to unmute?
Yes, please. Unmute.
I think go to the security setting and allow. Please check on people to allow, or you can make me the.
Yes, they can unmute themselves. Please round up so that we can close the session.
Yeah. Have you done that? I don't
yes,
think they can.
I've done that. They can.
All right. Okay. So, any questions? Anyone? Any questions?
Well, good evening, sir.
Yeah. Good evening.
So I really don't have a question, but I want to appreciate you. Thank you for making our time these 2 days to impact in us. We really appreciate it, sir. Thank you so much.
Thank you. And God
All right,
bless.
Innocent. Thank you very much, Dr. Tony. It's been very, very inspirational. And I think we would send the recorded session to the participants so they can actually exploit whenever they have their, this installed, SPSS installed in their laptop.
Yeah.
Dr. Anya Cora, do you have any contribution? Okay, I think she's
okay. So I think at this point we can call it a day. David, you can stop the recording now, and then I'll stop my screen sharing.